been guided by one ambition: to race. In 1978, two minds aligned and the FW06 was created. The start of great memories. Silverstone, 1979. The first Grand Prix victory, a grand stage on home soil.
As the years progressed, the team evolved, and so did our cars. Records tumbled, more silverware followed, more innovative, more iconic, more race winning, world championship winning, an era defined. Technology underpinned by constant innovation, driving performance to new heights.
Williams, we are racing.
Okay, good afternoon and welcome to a presentation that we decided to call Racetrack to Road and Beyond. We've got a double act. I'm on for the first 7 or 8 minutes, tell you a little about the Williams Group, some of our history, and look at some of the facets of our Formula One operation. I'm going to hand over to Craig Wilson. He's the Managing Director of our Advanced Engineering business. Tell you a little bit about what we're doing with the technology, the skills, the knowledge we've collected over a long time in Formula One. Williams is a British Formula One team. We were founded in 1977 by Sir Frank Williams and Sir Patrick Head. You heard Frank's voice on that opening video. This year, our 40th anniversary, and we're one of the most successful teams in Formula One. Only Ferrari has been around longer. We've won the Constructors' Championship 9 times, the Drivers' Championship 7 times. This is a neat photo. It's actually Nigel Mansell in the 1992 14B. That's Ayrton Senna he's giving a ride to on the way back to the pits after winning at Silverstone. Formula One is the world's most advanced, most technological, challenging motorsport series. It's truly global, 20 races across 20 countries. It's watched every other weekend by 500 million viewers. We're based south of Oxford. We've got a secure technology campus, a team of 900 people working across both Formula One and advanced engineering. Over the years, Williams has become synonymous with engineering excellence and innovation. Anti-lock braking, traction control, active suspension and composite technology, all of these disruptive technologies were developed at Williams under the intense competition of a relentless Formula One calendar. We're an engineering company that happens to go racing. It's at the heart of everything we do. Our sports regulations change every year. We build a new chassis each season. We're building it now for the new season that will start in February in Barcelona with pre-season testing. We hit our stride, though, during the season. We constantly update, prototyping new elements, looking to improve on lap times by tenths and sometimes thousandths of a second. We have to get it right first time. Let me give you an example. The front wing of a Formula One car takes around 2,000 man-hours to build. It has a life cycle of about 7 weeks. In that time, our aerodynamicists have dreamed up the shape. We've built the test parts. We've tested them in a wind tunnel. We've built the real thing, and we've raced it a couple of times. And then we move on updating it. The speed of innovation at Williams and at Formula One is incredible. The ever-present competition forces our engineers to assess new technologies and to adopt them or abandon them incredibly quickly. With a time limit on time and resource, we have to work as one team to achieve one goal, and it's teamwork that underpins that. I think one of the best examples of teamwork in a Formula One operation is the pit stop, where 22 men change the 4 wheels and tires on the car. We hold the world record at 1.92 seconds. There's not a whole lot you can do in 2 seconds. Just blink and you've missed it. It really is quite incredible. It's about innovation, dedication, and the teamwork in pursuit of success. Fine margins, sometimes just a few thousandths of a second, separate success and failure in Formula One. We have to constantly develop our capability to collect, display, and interpret data to drive split-second decision-making. You know, connected cars aren't new. Formula One cars have been connected for over 30 years. Our first race-winning car in 1979 had a 64K data logger. It took 20 minutes to download 1 lap of data. Nowadays, there are more than 300 sensors on the car. We sample more than 1,000 channels of data per second, and it takes less than a third of a second to transfer that race data from wherever we're racing in the world to our race control operation in the UK. Each race weekend at our race control centre, we have a team of data scientists, both at the racetrack and at the factory in Oxford, analysing data in real time to enable our strategists to make decisions in a split second in the race. The Formula One car is the ultimate R&D platform, and it's a platform that drives success beyond the racetrack. At our technology campus, we've got cutting-edge 3D printing, a model shop, a huge CFD cluster, 2 fully immersive simulators, 2 wind tunnels, a factory that operates 24/7, 365 days of the year, prototype and test facilities, an advanced lightweight structures operation, and all of this to run 2 cars in the ultra-competitive world of Formula One. Our knowledge, our skills, our technologies, and our facilities have been the genesis of a new business over the last few years. It's a business we call Williams Advanced Engineering. Thank you. Good luck.
Hello everyone, my name is Craig Wilson. I'm the Managing Director at Williams Advanced Engineering. We're the technology and services division of the Williams Group. Williams Advanced Engineering principally takes its technology, know-how, innovation inspired in over 4 decades of Formula One and applies it to a vast range of sectors and new markets. Just 7 years ago, Williams Advanced Engineering started as a single project business, and that was to create the Jaguar CX-75, the car that you can see pictured here. Jaguar asked Williams to help it develop and design a world-leading hypercar supercar. There's a lot of Formula One derived technology in this car. It had a carbon fibre chassis that was honed in our wind tunnels. It had all the bodywork developed in our CFD cluster, and it had a very highly tuned 1.6 litre turbocharged and supercharged internal combustion engine combined with a twin electric high voltage electric powertrain. The performance targets that were set for the car was to have the speed of a Bugatti Veyron, the emissions of a Toyota Prius, and the electric range of a Chevrolet Volt, which at the time was class leading. All of these very challenging targets in one vehicle and in a beautifully designed car. In just 18 months, we developed a number of prototypes that could demonstrate the performance, and Jaguar was able to use these as a technology platform to show the art of the possible. The CX-75 also subsequently featured in the last James Bond film, Spectre, and for those that have seen the film, it was the baddie's car. The car was the car that chased James Bond through the streets of Rome. The engineering challenge for the Bond film was even more extreme in terms of time. We had to produce special variants of the car in just 16 weeks. If you think about that in time, just 16 weeks. And these were ground up for the film. Not only did we manage that, but the stunt crew were delighted with the cars, and these cars were driven by highly skilled professional stunt drivers. And the car's performance was so good that the strapline on the film set was that it was good to be bad. So it was a great pleasure for us to be involved with such an iconic brand as Bond. The CX-75 embodied three of our main core capabilities, being aerodynamics and thermodynamics, energy storage systems, and lightweight structures and composites. We are driven to succeed, to innovate, and to constantly find new and better ways. We focus on global megatrends such as sustainability, climate change, urbanisation, to turn ideas into beautifully engineered solutions that deliver energy-efficient performance. Since the CX-75 project, Williams Advanced Engineering has grown dramatically, and we are now carrying out around 50 projects for 30 companies across the range of sectors, including aerospace, marine, defence, and healthcare. We have also a business dynamics division and an active technology ventures business that incubates and develops great ideas into commercial applications. The next few slides I'm going to show is just a small sample of the projects that we're currently involved with. On the screen here is the Dendrobium. This is Singapore's first fully electric hypercar with a standout lightweight design. We've used our comprehensive CFD capabilities and technologies to develop the aerodynamic performance. And much of the technology of the car was inspired by our Formula One know-how in how to lightweight and have composite structures incorporated. Secondly, in the blue capsule you can see in the foreground here is a project we've undertaken for Advanced Healthcare Technologies to design and manufacture a carbon fibre lightweight pod for critically ill newborn babies requiring emergency transportation. The design was inspired by the monocoque in the Formula One car, the safety capsule that the driver sits in and which protects the driver in the event of a crash. A number of hospitals are now trialling the baby pod, and we're receiving orders from across the globe. So it's good to see this innovation actually already making a difference in people's lives. So whilst those images highlight our capabilities in technologies and capabilities in aerodynamics and lightweight structures, we're finding that there is a growing trend towards combining that expertise with lightweight solutions with our other capabilities in electric propulsion, energy storage systems to create truly energy-efficient performance. At Williams Advanced Engineering, we design and manufacture our own batteries, electric motors, gearboxes, power electronics, and control software. And we're leaders in integrating EV technologies on a variety of mobility platforms. This image is the Brompton Electric. And having had experience with 4- and 6-wheel vehicles in our past history, we've now lent out technology to 2 wheels. Brompton recently launched this project, which draws our know-how in electrification. It features a small demountable battery, which is capable of being charged remotely and providing an additional energy supply, a lightweight, compact and powerful hub motor, and intelligent sensors and connectivity. And it can still fold and be carried in the iconic Brompton way. On a slightly larger scale, Williams Advanced Engineering has been the exclusive supplier of batteries to the entire Formula E series since it began. Formula E is the world's first fully electric racing series. We've drawn upon our battery technology, first used in our Formula One cars, to create a new battery system and battery management system capable of powering the Formula E cars. And that technology is now filtering into road cars. When it comes to batteries, people are often concerned about crash and fire safety hazards. We've incorporated a number of innovative features into our Formula E battery to protect against this. I remember the very first race in Beijing, and on the last corner of the last lap, Nick Heidfeld and Nico Prost, who were fighting for the lead and jostling for position, had a huge crash. Although the incident was obviously unfortunate for Nick Heidfeld, from a completely selfish standpoint, I was delighted that the battery was absolutely fine. It couldn't have been better for us in terms of technology validation, and it was, quite literally, the moment that launched the Formula E series. As battery technology continues to filter down from racetrack to road and beyond, and we see an increased number of hybrid and electric vehicles on our streets, we'll be faced with the challenge of what to do with these batteries in our cars when they've been removed from the vehicle. For example, some batteries may need to be removed from the car when they've exceeded their service life. But the batteries still have a useful life. So what do we do with them? So Williams Advanced Engineering has been working at solutions for second lifing electric vehicle batteries. We're currently working with a consortium, a European consortium called Net Efficient, to repurpose these batteries as energy storage systems. With an increased demand for smart energy storage, we're demonstrating how batteries from cars can have a second life. We've developed an interface and software that makes the battery believe it's still functioning in the car and enabling it to act as a dynamic energy source for homes, factories, and renewable grids. Electric mobility is coming fast. Electric mobility in many countries is already here. So what is the future of personal mobility? It's a question that a huge number of organisations need to think about and are thinking about in order to make the right strategic moves to form meaningful partnerships. Automotive OEMs, supply chain partners, technology integrators, and software developers. The personal mobility revolution is accelerating and industries are converging, a lot of which we've heard through the last 2 days of this conference. One CEO of a global automotive company recently said that there will be more change in the next 5 years than there has been in the last 50. The future is, however, very exciting. I can see a future where the technology in our cars is used as part of a new energy ecosystem. The car will increasingly play a much broader role beyond simply A to B transport. And with an ever-increasing amount of technology available for vehicles, the winners could well be those that manage the integration of these technologies in a smart and connected way, and find better solutions and performance through holistically integrated approach to design. Williams Advanced Engineering has therefore brought the best of our know-how to create an innovative, lightweight EV platform that we've called FWEVX. The FWEVX reimagines how electric cars could be designed and constructed. This new approach is designed to make EVs lighter, safer and greener, with longer range and better performance. The concept features several innovations in battery pack design, cooling systems and lightweight structures, and we've cleverly integrated into a single scalable platform. For example, our engineers have developed a highly automated, near-zero waste process that is being implemented to create fibre-reinforced suspension components, providing up to 40% weight reduction over a conventional aluminium wishbone. We've also developed a process of forming high-strength 3D structures from 2D materials, which in this instance was used to create an exoskeleton for the battery modules. The FWEVX also showcases an innovative cooling system that removes the need for a grille at the front of the vehicle, creating an improved aerodynamics and extra options for groundbreaking design. The battery is designed to be structural and adds to the vehicle's platform safety and strength. The FWEVX is a modular, lightweight EV platform capable of applications across a number of sectors and markets that include aerospace, rail, and defence. So it's not just an automotive platform, it's a mobility platform for the future. The title of this presentation that Mike and I have given today is Racetrack to Road and Beyond, and I hope that we've been able to demonstrate some of that today. On behalf of Mike and myself and all the team back at Williams, many thanks for your time this afternoon.